Hello bachcho, how are you? Hi students, very good morning to one and all. Here comes your Vignesh and your personal tutor and also home tutor and also online tutor as well. Now today let's start our class 3 session and we already had two classes before, that is for class 1 and class 2 on basics of trigonometry and some applications and some problems we have seen, right? Today let's go into the physics. Okay, this is our physics subject. It's also like normal MSET level, mains level and advanced level also. See, concept doesn't vary, the applications may vary, depends on the study of your standard of your studies. Okay, now let's go with the basic chapter, that is motion. Okay, in kinematics, okay, kinematics is a branch of physics or science, you can say, where it all deals with the motion. In kinematics you have static motion and dynamic motion. Static motion is say fixed motion, that means it's a motion with respect to some person. In dynamics everything will be moving, that means whatever we are dealing with respect to an object or with respect to some person, that will be in motion, and whatever we are considering, that will also be in motion, that is some dynamic. Now regardless of all those, let's start with our simple basic concept, motion. Okay, in class 8 also we have I think even SSC standards or CBSE also we have motion and its time, something like. Okay, let's solve. Now today the date is 1st September and we are going to start with our physics. Okay, and our chapter name is motion. Now applications of motion or Newton's laws of motion, whatever it is. See, basic chapter name is motion. It may be of different formats or different name kinds in different textbooks and materials. Now what do you mean by motion? Let's have a brief overview of this session. It's just an introduction section. It's not a very typical solving of problems of IIT or something else. Okay, what do you mean by motion? In general we say, now for example we are traveling in a bus. When our friend calls, where are you? We tell I'm in motion, like I'm moving, we'll say no. Will be like when you are bicycling, yes, and suddenly one of your friend calls from your behind of you, there's a friend is calling you, then you will be like in your motion, no, so you cannot just go behind that movement. So because your movement is in particular direction, that means generally the word which comes into your mind when you see the word motion is some movement or some traveling, right? Let's come to some definition point of view. Okay, let's be clear enough. Motion means the movement of an object from a one point to other point with respect to some other particular object which is in the state of rest or motion, or with respect to time, is known as motion. That means the body is said to be in motion. That means with respect to time or with respect to a static body, another body is changing its position from one point to another point, then that body is said to be in motion. Okay, let's try. Now let's say point A or clock, some time, some fixed time, or some point A, stationary point. Okay, stationary point. We can also tell it, the point may be in motion also. We will discuss that case 2. This is our case 1. Okay, like both are motions only. We'll see what's the difference. Stationary point. Okay, now point B at time t1 is at this point and point B is time t2 is at this point. So it is traveling a distance of, let's say, d meters. Okay, it's traveling this much. It's changing the position by d amount of units. Okay, now with respect to this point A at t1, it is here. With respect to point A at t2 is B at here. So now we can clearly say that In regard with A, this point B is changing its position within time t2 minus t1. Yes, in the span of this small time t2 minus t1, it's changing its position. So that body is said to be, that body in the sense here, that B, point B is said to be, is in motion in that time with respect to point A. See, always this motion is a relative concept. With respect to some other object or person or time, only you have to say the other body is in motion or not. That means it's changing its motion relatively or not. It's a concept of relativeness, not any other thing. Okay. Now see here, if the point A is also in motion, that means to be. Now I won't tell it's in motion. I just say that it's also moving. Moving is different, motion is different. Okay. It's A is also moving from this point to this point in time t1 to t2, and B is changing from this point to this point in time t1 to t2. Let's say in different times also, not an issue. It's traveling some distance, let's say small a, it's traveling some distance, let's say small b, but in the same time t2 minus t1, with respect to point A, this point B is changing its position. Yes, they are not moving at a constant speed, they are not moving at a constant distance also. Yes, this is moving, and with respect to point B, A is also moving, right? So with respect to points of each other, both are said to be in motion. That means A and B are said to be in motion with respect to each other, and as well as time also. With respect to each other, they are said to be in motion. That means with respect to A, point B is moving within time t1 to t2. With respect to B, point A is also moving from t1 to t2. Yes. So far we are clear about if a point is at stationary, and with regard to that point, the other point, how it is moving, and when we can tell it is a motion. And if it is not changing the position in this particular time, let's say any time t, then it's said to be at rest position. If it is in motion, it has to change position. If it is not changing position, that means if the distance changed is 0, okay, then it is said to be in rest position. Here also, if these two are in motion simultaneously, then they are said to be in motion. If this is moving and this is not moving, with respect to this, then also it may be said to be in motion. You understood? Now, if I tell this B is stationary, our case 3, if B is stationary and A is moving, with respect to A, B is in motion, and with respect to B, A is also in motion. Sir, how sir B is not moving? It is in fixed position. No. How can you say that it is in motion? No. Thing is, whether it's moving or not, I already said you, moving is a different kind of concept and motion is a different kind of concept. Thing is, with respect to A, it is moving. See, when you travel in a bus, you find from a window, the trees are going backside. Yes, we assume, but they are not going actually. But thing is, in our point of view, they are going what? Backside. That means, in our point of view, trees are in motion in our opposite direction. We are in motion in forward direction. With respect to trees, we are in motion. They are at stationary points only, but we are in motion in particular direction. But with respect to us in the bus, the trees are going in the backward direction. That means it is a relative concept. Again, I am telling, I am stressing very carefully. Please note down your definitions. I am not going to write each and every definition clearly. I am going to explain with the examples and case studies. So understand the concept over there and write your definitions in your own terms. Okay, in your terminology you can write, and please mention them. Keep a box or star mark, your wish. Try to understand the main synapse of it. Then you can create n number of examples. Here also, I said no, whether it's state of rest also, other particular thing is in moving means, that means that may be in motion with respect to this one, and this may be in motion with respect to that one. Clear so far? Okay. If you want, you can take a screenshot of it. Now, when we are discussing about this motion and all definition, we came across some words called distance and displacement. Do you know what is meant by distance? What do you mean by displacement? Yes? Now let's see what is distance, what is displacement. Now, distance. Let's say body A is a body or an object, anything, is said to be in motion, yes, and it is moving and came to some other point. Here the point is small a, object name is capital A, point is small a, and here point is small b, or let's say A1 to A2, A1 to A2. It's moving like this and like this, finally it came here. That means, let's say you are only traveling, you are walking in this direction, then took a right, then again you took a right, and you came to here. That means maybe you are coming from your college to school, or from school to college, or from school to home, or home to college. Let's say whatever it is, you are traveling this way. Whatever the path traversed by you or by the object from point A1 to point A2, the total path covered between the 2 points, or between the 2 points where the body is changing its position, is known as distance. See, again I am telling, the path or whatever the amount of you don't tell distance covered again here, you are defining the term distance itself. So you can tell the path covered by the object, the total path covered by the object to reach from point A1 to point A2, or between 2 points, is known as distance. This is known as distance. Now for example, from this point only, object A is moving like this. For example, object B or some other body, your friend, is taking from A1 to, he is coming like this, he is going this way, and he is coming like this, again he is going this way, coming like this, and coming to point A. Now his direction will be like this, like this, like this. Maybe he has some other work. Yes, maybe he has taken some long distance route, or maybe he didn't follow Google Maps or something else. He was asking the street members, and he took a long route and finally reached here. His path is very long as compared to path of A. That means distance covered by B is greater than distance covered by A. Got it? And some other person C may be there. He is very clever enough, he is very good enough, very smart. He may travel till short distance like this. Directly he may come to this point. This is distance covered by C, this is distance covered by B, this is distance covered by A. And distance covered by C is very less than distance covered by B. Here the order is distance C is less than distance A is less than distance B. All these are distances only. But thing is, here comes the second terminology, that is our displacement. What do you mean by displacement? Have you come ever across of this word displacement? It's a very simple, pretty clear word that the shortest distance between any 2 points is known as displacement. The shortest distance between any 2 points is known as displacement. Are you clear so far? See, option C, that means object C is taking the shortest distance right here. So we can tell as distance covered by C is known as displacement in this particular example. That means the shortest distance between 2 points is known as displacement. And always displacement is less than or equal to distance, because path travelled may be equal to displacement, yes, but displacement cannot be greater than distance, because it is the shortest distance, no, the minimum distance. This fellow can travel like this or like this, but the least most option or the minimum possible option is the shortest distance, right? Maximum he can travel infinite distance, but the shortest distance is nothing but displacement, and which is less than or equal to distance always, yes. Okay, now thing is, which is positive, which is negative, and which is vector, which is scalar. We have a question in our mind. You know what do you mean by scalar or vector? Scalar means which has only magnitude and it doesn't have any particular direction. Magnitude means what is magnitude? It has a value. For example, let's say what is your height. Now I tell like my height is 6 feet, sir. 6 feet. That feet is a unit, and the 6 is a magnitude. It's not any vector. Means it doesn't have any directions. Sir, why it can't have a direction? Height is also having vertical direction. No, we can tell some vertical in longitudes or latitudes. No. I'm not telling about longitudes or latitudes. In general, when we are measuring some object, we tell some length. No, that length or whatever is some length, maybe height or some weight, anything. In general, I'm telling about only the scalar point. Means it has a magnitude. The value is called a scalar. Distance is a scalar quantity. Means has only magnitude. But displacement is a vector quantity, has both magnitude and direction as well. Sir, what is direction again here? See, vector means it has a path in a particular direction and it has magnitude as well. Now this displacement you see, A to A2, A1 to A2, the C is covering like this. Maybe this is north or this is east, this is west, this is south. It is covering exactly some in particular southeast direction. Let's say the southeast direction is the quantity which defines the direction of the particular object C. Object C is moving in the southeast direction, so that is your direction, and magnitude is covering the distance DC. Okay, so we have both the quantities. That is called as vector quantity, and displacement is always vector quantity, and a vector quantity may be positive, negative, as well zero. But here displacement cannot be negative. Can it be positive or negative? Let's see. Yes, I don't say even it cannot be negative. It can be negative when like if you take coordinate axis, point is here. For example, let's say initial point A1, then A2. In positive x-axis, you consider displacement as positive. Plus D you can say. Same way if you go the other side, that is minus A2 point, the displacement becomes minus D2. Sorry, minus D. So it has a particular direction, no? With respect to some object, when you are traveling in the same direction, the displacement is positive. With respect to the object you are traveling in the opposite direction, or your consideration is in the opposite direction, the displacement will be negative. And it can be zero also. When it can be zero? If the body is moving some particular distance and coming to here only. See, point is here, it is going to this point and coming here. That means you are in college, you are going to home and coming back to college. So, what is the distance covered by you from your college to home to again college? That means from point A to B again to point A. What is the distance covered is? It is, if the distance between college and home is D, your distance becomes 2D. That means D you are traveling to home, again from home to college, again D. So 2D will be your distance, but displacement becomes 0. Sorry. Displacement becomes 0. Why 0? It is the shortest distance as I know. From the initial point to final point, how much it covered means, it covered this much. But what is now distance between initial and final point? Both are same point, right? When both are same point, it covered 0 displacement. Displacement is, for displacement I am writing dp 0. For distance I am writing d. D is 2d, too small d. Please note down this one, or I will write here. Distance can be always positive only, but displacement dp can be negative, 0 or positive. Please note down this point, it's very important. And scalar, vector quantity also, and this example also. Please note it down. If you have any kind of doubts or queries, you can please ask me in the comment box. I would love to solve your queries as well. And please take a screenshot of it. Let's erase this. Now let's discuss what is speed and velocity. Okay, what is speed and velocity. See, we already discussed about distance and displacement, right? I'm mentioning distance with d and displacement with dp. Okay. Now, our term is to know speed. You know what is meant by time? Time you already know, right? Okay, I need not again define time and give you some examples. Okay. Now, speed. First, I'm writing the formula. Distance by time, or total distance by total time also get. Total distance by total time. Now let's say a point A is moving from an object is moving from point A to some point B, and it's covering some distance d, small d. Okay, it's covering some distance small d. Now distance in time t1 to t2. t1 it started, t2 it ended. So time taken by this one is t2 minus t1 is the time, or which is equal to small d. Let's say in small d amount of time, it is covering this much distance d. So distance covered by the object is d and time is t. So speed is equal to s equal to d by d. This would be our basic formula. That means the total distance covered by an object in time t is known as speed. What is the unit, sir? Unit is SI unit is kilometer per hour and normal unit is meter per second, and 1 kilometer per hour is 1 kilometer means 1000 meters. 1 hour means 3600 seconds. It is equals to 5 by 18 meter per second. 1 kilometer per hour is equal to 5 by 18 meter per second. In calculation point of view, this formula would be very helpful in unit conversion and all. Okay, please note it down. Speed is nothing but total distance travelled by an object in the total time taken to cover that distance is known as speed. So distance upon time is nothing but speed, and from here you can make different kinds of formulas. Distance equal to speed into time, or time equal to distance by speed, whatever it is. Okay. On basically you can remember speed equal to distance by time, and here we are not talking about displacement. It is a distance. Okay, it's always positive and it's a scalar quantity, and it's always positive because our distance is a scalar quantity. So speed also becomes a scalar quantity. It's always positive, it's never negative. Okay, speed may be either 0 or positive. Okay, that means distance is 0 means speed will be 0. Okay, it's a scalar quantity. Okay, please note it down, take a screenshot of it. Now, just changing that, in place of speed I am writing as velocity, in place of distance I am writing displacement. Okay, now point A has to an object A has to travel from point A to point B. An object A has to travel from point A to point B. Now he has to go in shortest path because of displacement. Now let's talk about displacement. He is traveling in this particular direction, let's say some south east direction, and distance covered is dc. Let's say dc is the displacement, not distance. Displacement covered by the object from point A to point B in time t2 minus t1, that is time t again. Okay, that time gap interval is t seconds or t minutes, t half, whatever it is. Okay, I am not bothering about unit here. Time is t units from t1 to t2. So displacement covered is dc. So our velocity becomes dc by dt, or dc by t. Sorry, dc by t. That means displacement covered by an object in a particular time t is known as velocity. And velocity is a vector quantity and units are same, kilometer per hour or meter per second. Vector quantity which has both magnitude and direction, as well. Generally we denote any vector in the I cap, j cap, some caps, right? That means it is in which direction, I cap, j cap or k cap, positive x axis, negative x axis, or positive x axis, y axis, z axis, like that. Same way here also we define vector quantity with respect to these directions, and in general we can have some vector values like 2i plus 3j minus 4k cap. That means it is 2 units positive in x axis and 3 units positive in y axis and 4 units negative in z axis, because it is minus. That means in space, if you think this x, this y, this has z, 2 units here, 3 units here and 4 units in the negative z axis. This is positive z axis, let's say this is negative z axis, 4 units here. So the point may be somewhere around here, maybe the point may be here. So 2 comma 4 comma 2 comma 3 comma minus 4. Thing is, you need to know the definitions as well as quantities, formulas, etc. So how do we define velocity? It is quite similar to speed but not speed. It's a velocity. Velocity means the total displacement covered by an object in a particular time interval t is known as velocity. Now for example, the object is traveling from A to B and covering the displacement of dc in time t, that is t2 minus t1 is equal to t. So displacement of this particular object is known as dc and velocity is known as dc by t. So velocity equal to dc by t. Same way you can write displacement is equal to velocity into time, and time is equal to distance, displacement by velocity. And velocity may be always positive or negative or zero also. If the displacement is zero, velocity is also zero. If the displacement is negative, velocity becomes negative. If displacement is positive, velocity is also positive. Depends on the unit and magnitude of displacement. Please take a screenshot of it. If you have any kind of queries, please mention in the comment box regarding distance, displacement or velocity and speed also, or any particular topic in motion. And if you want any particular detailed, minute explanation also, I am very glad to help you all. Please mention in the comment box, okay? Please take a screenshot of it. And this is all about our session, very brief introduction about motion topics, distance, displacements and their units, speed, velocity and their units. And this is our class 1 in physics. Actually it's our class 3, but in physics point of view it's our class 1. So I'll upload in a separate playlist this one, physics class 1, where you can check out this video. And for further videos, you already know, like my video, please subscribe my channel and share it, and mention your comments please. If you have any doubts and queries and any kind of further help also, always we can provide you with the better facilities and all. And I'm always there to help you all. And click on bell icon for more updates, okay? Signing off, this is your Vignesh. Bye bye.